So my name's Greg Watson. I'm a research scientist at Oak Ridge National Lab, which is one of the Department of Energy laboratories in the US. It's actually based in Tennessee, although I'm physically located in New York and I work remotely most of the time. Oak Ridge has been a long-time contributor to Eclipse. I've been involved with the Eclipse Foundation since 2005, I think, was the first EclipseCon I came to. And I've had various different roles. But recently we came across this, or came against this particular issue, and I wanted to talk about that today and relate my experiences with this. So essentially, we do a lot of web development at the lab. Well, you wouldn't think so, because most of the things the lab does are to do with science, but we do develop a lot of web-based applications and Java applications. And that's why we came up against this particular issue. So basically, software engineering 101 is that you want to try and reuse as much software as you can. Everybody is familiar with that. So I found some stats online that as of September 2018, there was about 162 million lines of code being hosted at the Eclipse Foundation. And of that, about 72 million lines of Java. I don't know what all the rest of the code is. I guess it's HTML and other stuff. But anyway, so there's like a huge amount of Java code there. And so what happened was that we were developing a particular application. We knew that there was functionality available in Eclipse plugins to do that, but we didn't want to have to take on the entire Eclipse ecosystem and OSGi and all that kind of stuff in order to utilize that functionality. So we wanted to essentially treat Eclipse, the Eclipse Foundation code base, essentially a big toolbox. We would like to just take pieces of that and use that in our applications. And then hopefully we'll get the benefits of the reuse. So that was kind of the motivating point. So what do we want to try and do? So this talk, and I should actually ask people, so is everyone here familiar with OSGi, like the technical details of it? Is everyone anyone not programmed in Java? Okay, so we're all Java programmers. So you guys might know more about this than me. If you do, I'm happy to talk to you later about, suggestions. So anyway, what we want to do is create an application that's not OSGi based, but we want to make use of services and other kinds of functionality provided by OSGi bundles. So that's basically what we want to do. So there's a few ways to do that, and I'm going to talk about them later on. But the way that I embarked down this little rabbit hole was looking at this notion of embedding an OSGi framework. So a lot of the frameworks provide this functionality where you can have a host application, and then within that host application you can embed an OSGi framework, which then does all the bundle management and all that kind of stuff. So that's the route that I picked to go down. And what I'm going to tell you about is my experience with that and what I was able to achieve and what I wasn't able to achieve. So the first attempt at this was to, so I want to create this application that is sort of part OSGi and part not OSGi using an embedded framework. So what I did to start with is the other thing I should point out is that the OSGi bundles I want to get from Eclipse, right, or the Eclipse Foundation. So they're P2 bundles. So I had this added problem that I had to access a P2 repository, not some other kind of repository. So what I did was I utilized the Tycho Maven plugin, which very conveniently is able to retrieve bundles from P2 repositories and will also retrieve transitive dependencies as well. So what you can do is you can create a pom.xml that specifies the P2 repository location. This time, for this, I just use download.eclipse.org. You can also add in the normal, I was using Maven, right? So in the normal Maven dependencies, you can also specify additional dependencies that you want. In the manifest file, you specify the actual bundles that have the functionality that you want. And you have to mess around with target platform configurations if you want to retrieve fragments as well. So that's a bit messy. And then you can combine that with the Maven dependency plugin to essentially retrieve these bundles, retrieve all the dependencies, and stick them in a directory somewhere that you can then use for your application. So that was pretty straightforward, very minimal little project, you know, not very many lines of code, although it did take a while to figure out how to get all these things to talk to each other. Anyway, that was the first step. So then the second step was to create a Maven-based application, and I just picked Maven because we were using Maven, but you know, this would equally apply to Gradle or anything else. And what we want to be able to do is reference these bundles on the class path, because from within our non-OSGi application, we want to be able to access the APIs and functionality provided by these bundles. So in the Maven dependency specification, you can actually manually specify the path of these bundles. Now this isn't ideal, you wouldn't probably want to do this in practice, and there may be ways of doing this more automatically, but this was really just a proof of concept. So, so for bundles that weren't available in Maven repositories, that's what I did. It turns out that Eclipse is now publishing a lot of their bundles to Maven Central, so you can just put them in the dependency and it'll find them. So there's some that are up there in Maven. There's some that aren't there, which you have to specify using a like a directory path to get them. But anyway, that created my simple application. And then the third thing I did was I implemented a simple embedded OSGi framework, which is necessary to load the bundles. So you've got to go and you've got to find the bundles and you've got to load them into OSGi in order for them to work properly. And I used Felix to start with, just because I picked, you know, an OSGi framework, which I thought was pretty lightweight and could probably do the job. So does anyone want to guess what happened when I tried to run this application? Any guesses? Okay. So when I tried to run it, class cast exception. So the first time that I used an API in my application, and then I tried to, so I like got a service, the service had an API, and then I tried to do something with that, I got this class cast exception. So basically that was a failure. So so why is that? Well, so one thing that many Java programmers probably don't know is that a class is defined by more than just its name. There's actually two things that define a class in Java. There's the name of the class and the package that it's in, but also the class loader that loaded it. And that's a really important thing, because class A loaded by class loader X is a completely different class from class A loaded by class loader Y. And if you try and assign those two classes together, you will get a class cast exception. And that's what was happening. So why is that happening? Because Java itself, normal Java applications use a particular class loading scheme, which is this hierarchy, starting at the boot class loader, which loads all the java.star packages automatically for you. Then there's a extension class loader, which loads any extension packages. And then finally, there's an application class loader that loads the classes associated with your application. And there actually can be more levels than that. And each one of those class loaders, the children can see all the classes loaded by the parents. So it's this hierarchical thing. If a class loader, the first thing it does when it tries to load the class is it delegates it to its parent. If that parent can't load it, it delegates it to its parent, and so on up the tree. And then eventually, if the root of the tree can't load that particular class, then it will say to the next level down, well, you try, and eventually it'll come back down to the actual class loader that can load it. So it's this hierarchical delegation mechanism. OSGi, on the other hand, people are probably familiar with this, is a completely different model. So OSGi, every OSGi bundle has its own class loader, and essentially the only delegation that an OSGi class loader will do is if it needs to load an imported package. So if you say, okay, I'm importing a package X, and you try to load a class, then the class loader for this bundle will delegate it to the bundle that exports package X, and so then it will get loaded. And so instead of a hierarchical set of class loaders, you have this sort of network of class loaders. So completely different class loading schemes. So that's fine. I mean, it doesn't matter that these two things are different, except in the case where you try to use a class from a bundle, you know, using the non-bundle class loader essentially. And a classic example of that is an API. So your bundle exposes an API and you want to use that in your main application. And so if we add that bundle to the class path, the class loader for the application will happily go and load this class. But the problem is that when the bundle gets loaded and the bundle itself loads that class, then it uses a different class loader. So essentially they're incompatible classes, and that's where you get your class cast exception from. So what to do about that? Well, there's a bunch of different ways that you can solve this problem. I'm going to just talk briefly about two. One is called system packages and the other is boot delegation, but there are some other ways of doing it which are essentially variations of these two. So with system packages, there is a property that's part of OSGi that allows you to list packages that are automatically exported by the system bundle. So the system bundle is the one that gets started first by the framework. And you can, so that system bundle actually gets loaded by the parent of the framework class loader. So whatever class loader loaded the framework, the parent of that is the class loader that will load the system bundle and consequently any classes that the system bundle loads. So what you can do is you can, using this property, you can list all the packages that you want to use in your application. And so in theory, you should be able to just use them because those packages should be, or the classes associated with those packages should be loaded by the parent of the framework class loader, which is the application class loader, which should be the same class loader as the one that loaded your application, in theory. The problem is, there's two problems actually. One is that if a bundle exports its API, but also provides an implementation of that API, but doesn't import its own API, then it will never go to it'll never delegate its loading to anybody else. It will always just use its own class loader to load. And so it will never, using this scheme, it will never get to the application class loader. So it turns out that if you look at Eclipse plugins, very few of them import their own APIs. Like they just don't do that because they don't need to. So that's a big problem. And then the other thing is that you have to list every single package that you might want to use on this property, and that includes even packages and classes that are indirect. So say you've got an API that uses like the file system, a file store interface or something like that, and it returns an IPath which is in a different package, then you have to know that you have to list both those packages on this property. And so figuring out like all those packages, well, is problematic. So even after fixing all those things, I still couldn't get that to work. So for me, this was a no-go. So and this is just an example. I just quickly did a dependency diagram from one package. So the one I was trying to use was this org.eclipse.remote.core, and these were all the dependent bundles just on that one bundle. And the ones in red are even worse because they're split packages, which means that they're bundles that export the same package, and that also causes massive problems. But you can see the complexity of trying to figure out like which packages to export and stuff. Anyway, so the other method is called boot delegation, and this is essentially used by frameworks so that certain packages will automatically be imported. Things like Java, for example. So you don't actually have to put an import. You don't have to say import java.lang. It's automatically there for you. And so you can, using this property, you can specify which packages you want to be loaded. And the other nice thing about it is you can put wildcards in there. So instead of listing every single package, you can put org.eclipse.star and it will just get all the org.eclipse ones. The documentation recommends not doing this because you're essentially getting around the whole point of having OSGi, which is being able to have different versions of bundles. And so essentially everything's being loaded by the same class loader, and so you could run into version problems. But this was the only way I could get it to work at all. So my second attempt was to add boot delegation. So I took the same app, all the same stuff, and I added boot delegation. Anyone want to guess what what happened this time? Okay. How am I going for time? Okay. Okay, so this time I got a class cast exception again. So, fail again. But this time it was a different class cast exception, okay? It wasn't trying to just assign to interface like the same class to the same variable or whatever, a variable of the same type. This was a different class cast exception. So what happened this time? So it turns out that Eclipse plugins can only be used with Equinox. So in my naive starting point, I thought, well, let's just use any framework, any OSGi framework, but you can't. And this is because essentially Eclipse bundles and the Eclipse platform assume that the system bundle, the first one that gets loaded, is the Equinox system bundle. And in fact, if you look in that bundle, it gets past an interface, it gets past a bundle context, which is an OSGi interface, but it immediately type coerces that into an Equinox bundle. So if the thing that's passed in is not a concrete type of Equinox bundle, then all hell breaks loose. And in fact, Felix passes in a bundle impl, which is its bundle implementation class. And so that's why I was getting this class cast exception. Yeah, so that's what was going on. So that was a bit annoying. But anyway, so my third attempt was get rid of Felix and go to Equinox. So I replaced all my Felix code. Not that there was that much code, but you do things in Felix in a completely different way that you do them in Equinox. So I had to figure out how Equinox did all this stuff, loading bundles and stuff. And so I tried that. Anyone want to guess what happens? Class cast exception. Actually, no, a bundle exception this time. So this failed. So why did this fail? Because in theory, the class loaders and everything should be working. I've got around this problem with the fact that I'm using the wrong OSGi framework, So what's going on now? Well, it turns out there's this thing called bundle start level. Now, bundle start levels are something that if you read the OSGi spec, it says, you know, this is not something that you should really use. I mean, and if you read what people say, they say, no, you should design your bundles so they're independent little units of work, and there shouldn't be any dependency from one bundle to another. But there are certain situations where you want a bundle to start before another bundle. So in Eclipse, you want to throw up, you know, the logo at the beginning. Okay, so you've got to somehow make that bundle load first. So to hack around this, they implemented start levels. And so essentially that this is global information, right? You have to know that bundle X needs to be started before bundle Y or it doesn't work. And where's that information stored? Nowhere. I mean, it's stored in the product definition, you know, file for an RCP application. That's the only place you can find it. It's not documented anywhere. This magic information, you know, you have to ferret out and figure out yourself somehow. But anyway, there's one thing, if any of the bundles access the workspace, then you have to make sure that the workspace has been configured and opened before you can even start these bundles. So that's one thing you can kind of look at to figure it out. But I ended up doing it by trial and error, which was like start them, try and work out which ones were failing, and then start them later. And eventually I got to figure out the start levels. So on my fourth attempt, so I added a start order. Now, to do that in Eclipse, basically what you have to do is you have to take the URL to the bundle and you have to add the start order to it as part of the string, and then Equinox will kind of just load it in the right order for you. So anyone want to guess what happened now? It worked, yay! So it took 4 attempts. Actually, it was a lot more than that, but so I actually got the application to run. So what does this mean in practice? So what this means is that if you've got a Maven build application, it's not just a matter of adding, you know, a bunch of dependencies to OSGi bundles and it will work. I mean, we kind of knew that, right? So what you've got to do at the moment is you've got to create a separate project to manage the OSGi dependencies. So you've got your Maven project, you've got to create a separate project to do that. Then you've got to hack your Maven configuration to reference those dependencies manually and add them to the class path. You've got to use Equinox and nothing else. This is if you want to use Eclipse, right? If you want to just use any OSGi bundles, then you might be able to get away with Felix, but if it's Eclipse bundles, you have to use Equinox. You've got to use boot delegation or it won't work, and you've got to somehow know the start level thingies or just things break, okay? So that's what I learnt basically from this exercise. Not the easiest way to create an application, right? To figure out all this stuff. What I wanted was just like a Maven plugin that would do all this for me automatically. But I wasn't going to get that. Okay, so what are the other options? So there are actually a few other options, and I'm just going to talk about these very briefly. Wrap the application code in a bundle, convert it all to OSGi, rewrite Eclipse plugins, or use OSGi remote services. So, wrapping the application in a bundle. So it turns out that programmatically you can take your application code and pretend it's a bundle. So for example, you can write the bundle code and then you can just instantiate a class that is your application. And then you can tell Equinox that this thing is actually a system bundle, and it will kind of pretend it's a bundle. So the nice thing about that is then once it's kind of wrapped as a bundle, then you get around the class loading issue because it's just then treated by OSGi as another bundle, and so all the class loading works. But it doesn't help with the start level problem, okay? Nothing helps with that. You're stuck with that forever. And it doesn't really integrate that well with Maven still, because you've got to have, you know, a separate project to manage your bundles and everything. So I gave this a tick because it's easier for the developer. It's, you know, they don't have to mess around with like trying to do the class paths and all that sort of stuff. But there's cases where it doesn't really work. Okay, why not just like people will say, well, why don't you just do an OSGi application? Why are you messing around with this? Well, because that's not always possible. Okay, we have a lot of applications we've already written. They're not OSGi. They just use Maven or Gradle or something. The effort to convert them to OSGi would be too big. We don't want the complexity of dealing with OSGi. And then once we do that anyway, then we're tied to OSGi, and so we might not want that to happen. It's certainly an option, and if you're developing Eclipse plugins or something like that, then sure, you know, you would do that. But it doesn't really solve our original problem, which is trying to make non-OSGi applications work with OSGi. Okay, so why not provide non-OSGi versions of the bundles? Okay, that's another way to go. Well, you know, rewriting the 72 million lines of code, you know, so that they work in a non-OSGi environment is not practical. It's not particularly good reuse. I mean, you might be able to reuse some of the code, but I'm sure you'd have to write other code. And in some cases, you're going to have two versions, and really it's not desirable to maintain those. So, I mean, this would be fantastic if I could just have every single Eclipse bundle in a Maven repo, and it's not OSGi enabled or linked to OSGi anyway. That would be very easy, but this is just way too much work, so it's not really practical. Another option is to use OSGi remote services. So that gets around the class loading issue, because you're running in different address spaces, so you're running in different JVMs actually. So you just separated the class loaders. They're completely different. The OSGi remote services handles the communication and the serializing and all that kind of stuff. So that is an option, but it's quite a lot of work to integrate that into an application, especially if it's not an OSGi application to start with. And then you've got the issue of efficiency, because every time you're doing an API call, you're serializing your arguments and deserializing them and all that kind of stuff. So, so I gave that, you know, that definitely solves the class loading issues, but it's too complex an approach. Right, so what's the next steps? So everything I've talked about has problems. There's no doubt about that. I think there's two enhancements that would make this easier. One is a plugin for Maven that essentially you could just specify a P2 repository and then specify your dependencies as you normally would, and then it would just take care of building all that for you automatically, like downloading the transitive dependencies, putting them in a directory somewhere, and then making that available to your OSGi part of your application. So there's the bun tools. They have a plugin that does some of this, and there's also the Maven bundle plugin, which also kind of does some of this, but nothing does really this exact thing. The other thing would be if you modified the framework, the OSGi framework launcher, so that it just automatically included the main application as a system bundle. So rather than having to mess around with like creating the bundle and all that sort of stuff, if it just automatically did that, so it assumed that the code that was used to launch the framework was also in the system bundle, then that would just solve a whole lot of problems. Now, obviously, you wouldn't want that in all situations, but it could be an option, you know, for the framework to do that, and then that would make my life and other people's life so much easier. So they're two things which are not that complicated to do, which I think would make life a lot easier. So just to conclude, basically OSGi and non-OSGi applications live in completely separate worlds defined by their class loading strategies. So this is a really difficult bridge to cross, but it's not impossible. So I've showed that you can do it. It's just hard to do, and it's not something that the average developer would want to do. I think there would be a lot of benefit to both the non-OSGi and OSGi communities if this was made a lot easier, because you would automatically, the communities would increase in size, right? So the non-OSGi people have access to all this functionality provided by Eclipse and other OSGi people, and then they would be willing to contribute, I would think, back to those communities and vice versa. So I think it could have a lot of payoff. And essentially, I think there's not a lot of work that would need to be done that could make that happen. And yeah, as I mentioned, I think the payoff could be quite significant. So that's it. Any questions? Yes. Yeah, so, well, there were two problems with OSGi remote services. One is the overhead. Now, if your application is going to be remote, great, like that would work really well. But if you're just writing a standalone application, then having every call be serialized and deserialized could add a lot of overhead. And also, the part of the OSGi remote that sits in your application is still part of OSGi, so you still have to figure out how to get that part to work. So there's still some issues there. So definitely an option, but I just think it was too complicated and potentially might introduce too much overhead. But if your application is already distributed, then it could be a really, good option. Any other questions? Yeah. Why did I do it? You might have missed it. Yeah, so we develop a lot of applications that are not OSGi, right? They're just standalone Maven web server applications, or we use Spring or whatever. And recently we were developing an application, and there was functionality that we knew was in the Eclipse ecosystem that we wanted to use, but we didn't want to reinvent it. There was a lot of code. We wanted to try and reuse it. And so I thought, well, can we easily reuse this functionality in our non-OSGi application without converting the application to OSGi? So that was the motivation for doing it. I haven't got to that point yet. Like, I've just demonstrated that you can do it, but it's still, because it's so difficult to do, I'm not going to say to our developers, okay, go and do this yet. I want a few more pieces like the Maven plugin, and also maybe a modified launcher or class loader or something that takes a lot of the pain away, and it all happens under the covers. Yes. In this case, it was part of the org.eclipse.remote project. So that provides a high-level API to accessing remote functionality via SSH, and also other types of protocols, but particularly SSH, because we work in high-performance computing. The only way that you can get to a machine like one of the supercomputers is via SSH. You can't run a web service on there. You can't do anything. Like, it's firewalled off. It just has an SSH port open. So we have to run everything across SSH. So if we want a user interface of some kind, we have to tunnel all that through an SSH connection. So the org.eclipse.remote functionality provides that. So yeah, that was the particular case. Yep. Any other questions? Okay, well, I hope you found it useful. I'm around for the rest of the week if you want to talk more. If anybody, has any ideas about how to make this better and wants to talk about it, I'd be happy to. But thank you.